Hello everyone, I am Dheeraj Shriyan, a GenAI expert at Pi/3, and today I will be showcasing our project on AI-assisted prostate cancer detection system. The system demonstrates how deep learning and generative AI can work together to support clinicians in early, accurate, and reliable prostate cancer assessment using both clinical data and MRI imaging. Now let's first understand what are the key challenges in prostate cancer diagnosis. Prostate cancer is one of the most common cancer among the men worldwide, making early and accurate detection extremely important. However, early stage prostate cancer is often asymptomatic, meaning patient may not show noticeable symptoms until the disease progresses. MRI plays a crucial role in detection, but interpreting prostate MRI requires a high radiological expertise. Lesion appearance can vary significantly across patients, which adds to the complexity. Currently, much of the analysis relies on manual assessment, which is time-consuming, subjective, and prone to interoperability. Challenges highlights a need for more consistent and scalable approach. Now, let's understand why solving these challenges is so important. Prostate cancer affects millions of men globally, and delay in diagnosis can lead to progression, reduced treatment option. At the same time, overdiagnosis can also be harmful, resulting in unnecessary biopsy, increased patient anxiety. Because of this, there is a strong need for early, accurate, and reliable decision support system that can assist clinicians while improving patient care. To address these challenges, we built an AI-assisted clinical workflow for prostate MRI analysis. Let me briefly walk you through the system flow shown in this diagram. The workflow begins at input layer. We collect patient demographics and clinical information including name, age, gender, medication, and symptoms. Second, we take multiparametric prostate MRI inputs, which includes a T2 weighted axial MRI slice of the entire prostate gland for anatomical assessment, diffusion weighted imaging at low and high B values, and a corresponding ADC map. The system strictly supports axial imaging only, with consistent slice selection and identical spatial alignment across all MRI sequences. The DWI and ADC input focuses on radiologist selected region of interest or suspicious lesion are first passed to the CNN-based deep learning model. The model performs a lesion-level classification, determining whether the findings are clinically significant or non-significant. If the findings are clinically significant, an automated alert agent triggers a clinical notification email, ensuring timely attention. At the same time, the classification result output are passed to the large language model in parallel to the patient's clinical information and T2 weighted MRI input. The LLM performs clinical reasoning and forwards this to clinical report generator agent, which produces a structured assistive clinical report. Now that we have seen the workflow end to end, let's move to the actual demo of the system. The system is designed to support radiologist-driven interpretation of multiparametric prostate MRI. On initial load, the system presents an overview of complete workflow along with its key clinical constraints. The analysis is strictly restricted to axial imaging only, with mandatory slice consistency and identical spatial alignment across all MRI sequences to ensure reliable downstream analysis. On the right side of the system, the user enters basic patient demographics and clinical information including name, age, gender, medication, and presenting symptoms. This information is later incorporated into AI-generated clinical report, providing a necessary clinical context for interpretation. Now, to begin with the imaging workflow, the user selects the option to upload multiparametric MRI data. The system enforces a guided sequential upload process, ensuring correct image ordering and maintaining a strict consistency across all MRI sequences. The first required input is T2 weighted axial MRI slice of the entire prostate gland. These images provide a global anatomical constraint and later used for structured anatomical report generation. Next, a diffusion weighted image with B-val between 400 and 800 seconds per millimeter square is uploaded. Only a crop region of interest focusing on suspicious lesion is provided rather than the full slice. This is followed by a high B-val diffusion weighted image between 1000 and 2000 seconds per millimeter square. The same spatial coordinate and crop are reused to maintain consistency across the diffusion sequences. Finally, a corresponding ADC map is uploaded using the identical region of interest and spatial alignment. Strict spatial consistency across DWI and ADC input is enforced to ensure reliable lesion-level analysis. Once all required MRI sequences are successfully uploaded, the system confirms completion of multiparametric MRI inputs. At this stage, the data is fully prepared for AI-assisted cross-sequence analysis. The user then initiates analysis process. In the backend, the lesion-level diffusion data is analyzed to determine whether the findings are clinically significant or non-significant. In parallel, the T2-weighted MRI is processed to generate a quantitative anatomical assessment of the prostate gland. Once the analysis is complete, the AI prediction is displayed in the left panel. This includes the predicted classification, the confidence score, and a unique record identifier for traceability. The system also provides access to the generated clinical PDF report. PDF report integrates AI prediction, anatomical observation derived from T2-weighted MRI. The report is presented in a structured, assistive format intended to support clinical decision-making under the supervision of a licensed healthcare professional. The system also includes a record page where all previously analyzed cases are stored. Each record contains patient details, AI prediction and confidence score, date and time of analysis, access to the corresponding PDF report. This enables case review, auditing, and longitudinal tracking of all analysis performed using the system. In summary, the system demonstrates a complete AI-assisted prostate MRI workflow focusing on consistency, reproducibility, and clinical interpretability. This concludes the walkthrough. Thank you.